Hi, this is Avin. Welcome to my channel Tricks World. In this video, I'm going to deal with Cbse Class 10, Chapter number 8, Trigonometry. This trigonometry is a Greek word. Tri means three, gno means sides of a triangle, and metry means measurements. Trigonometry gives relationship between the sides of a triangle and the angles. Before we start this topic, let us see what are the benefits we are going to get from this chapter. In board exam, this topic carries 12 marks weightage. That means you are going to get good number of marks from this topic. Second is, you can have astonishing benefits from this chapter. You will be able to find the height of mountain or Mount Everest without actual measuring. Imagine a plane is flying in the sky and you will be able to find how high the plane is flying from the ground without actual measuring. You can tell. Imagine that this BC is a building just on the bank of a river, and you are observing any object on other side of the river bank, then you will be able to find the breadth of the river without actual measuring. How you are going to do all these things, I will explain you step by step. Here we go. As we know, trigonometry gives relationship between the sides of a right-angled triangle and the angles between them. We should know the names of these sides of a right-angled triangle. Imagine that we are standing at the angle A and we are observing from angle A. So this side BC is opposite to angle A. Once again I repeat, we are standing at angle A or we are observing from angle A. The side BC is opposite to us. Therefore, we call it as this is opposite side. And the side AB is just beside us, that is just adjacent to us. Therefore, side AB is called as adjacent side. This is adjacent side. And we know in right-angled triangle, the side which is opposite to 90 degree, it is called as hypotenuse. Therefore, side AC is called as hypotenuse. And here we have to remember, we are observing the triangle from angle A. Therefore, side BC is opposite side and side AB is adjacent side, and the side AC is in front of 90 degree angle. Therefore, it is hypotenuse. Imagine if we are observing this triangle from angle C. We are standing at angle C or we are observing this triangle from angle C, then the side AB is in front of angle C. Therefore, this side AB will become opposite side and the side BC becomes adjacent side, and the side AC, it is in front of 90 degree angle. Therefore, it is hypotenuse. So, whenever we name the sides of right angle triangle, we should take into consideration that from which angle we are observing the triangle. Now, for time being, we are observing this triangle from angle A. That means we are standing at angle A. Therefore, side BC is opposite side, side AB is adjacent side, and side AC is hypotenuse. Let us learn now trigonometric ratios. In one of my video, I have told you that ratio means something divided by something. For example, 3 divided by 8. Or we can divide a side by another side. That is also a ratio. Here we are finding trigonometric ratios means we are going to take the ratios of sides of right angle triangle. How many possibilities are there? We can divide this side by this side. This is one possibility. We can divide adjacent side by hypotenuse. This is second possibility. We can divide opposite side by adjacent side. This is third possibility. We can divide adjacent side by opposite side. This is fourth possibility. We can divide hypotenuse by opposite side. This is fifth possibility. And we can divide hypotenuse by adjacent side. This is sixth possibility. So there are 6 trigonometric ratios we are going to learn in this topic. Now let us see what happens if we divide opposite side by the hypotenuse. Opposite side, I write in short, by hypotenuse. What is opposite side? BC. What is hypotenuse? AC. So this ratio is called as sine ratio. That is called sine. And we are observing this sides from angle A. Therefore, we call it as sine A. Therefore, sine means opposite side upon hypotenuse. We have to remember, this is very important. We have to remember these ratios because these ratios are very useful while solving numericals. I repeat, sine ratio means or sine A means opposite side upon hypotenuse. This is first ratio. Second ratio is I can divide adjacent side by hypotenuse. That is adjacent side by hypotenuse. That is adjacent side means AB, hypotenuse means AC. This ratio we call it as cos. Cos is the short form of cosine. Cosine is written in short cos. Cos means adjacent side upon hypotenuse. When we divide adjacent side of a triangle by hypotenuse, this ratio is named as cosine or in short cos. Now, third ratio. The third ratio can be obtained by dividing opposite side by adjacent side. Third ratio can be obtained by dividing opposite side divided by adjacent side. What is opposite side? Opposite side is BC. What is adjacent side? That is AB. This ratio, opposite upon adjacent side, is known as tan A. That is, tan is nothing but opposite side upon adjacent side, that is BC upon AB. This tan ratio can be written as sine A upon cosec. Why? Why? Tan can be also known as sine upon cos because we know that sine means opposite side divided by hypotenuse, cos means adjacent side divided by hypotenuse, hypotenuse get cancelled, again we get the same ratio opposite side upon adjacent side. Therefore, tan A is nothing but opposite side upon adjacent side, or in the place of tan A, we can also consider sin A upon cos A means also tan A. Now, fourth ratio, we can divide adjacent side by opposite side. That is, adjacent side divided by opposite side. What is adjacent side? AB. What is opposite side? BC. This ratio, adjacent side divided by opposite side, is known as cot. Cot A is nothing but adjacent side upon opposite side. We can also get this adjacent side upon opposite side even if we divide cos A divided by sin A. We know that cos A means adjacent side divided by hypotenuse. Sin A means what? Opposite side upon hypotenuse. Hypotenuse get cancelled and again we get adjacent side upon opposite side. Therefore, adjacent upon opposite is known as cot A, or we can also consider cot A is nothing but cos A divided by sin A. We can also say that cot A is inverse of tan A. See, cot A is also inverse of tan A. How? What is the ratio of tan A? Opposite upon adjacent. Opposite upon adjacent. And it will be inverted and we get adjacent side will go to numerator and opposite side comes to denominator. Therefore, cot A is nothing but 1 upon tan A. Cot A is nothing but cos upon sin A. We have to remember, because while solving the numericals, we have to substitute in many cases. Instead of cot A, we have to substitute cos upon sin A. Instead of tan A, we need to substitute sin A upon cos A. So such conversions are very important. Therefore, we have to remember all these ratios. Now let us see the fifth ratio. Fifth ratio can be obtained by dividing hypotenuse by opposite side. Hypotenuse by opposite side. What is the name of hypotenuse? That is AC. What is the name of opposite side? That is BC. This ratio is known as cosec A. Cosec is nothing but hypotenuse divided by opposite side. We can also say that we can get the hypotenuse divided by opposite even if we take inverse of sin A. Therefore, we can also say that cosec A is nothing but 1 upon sin A, or we can say hypotenuse divided by opposite side. Now, the last ratio we can get by dividing the hypotenuse by adjacent. Hypotenuse, when it is divided by adjacent, hypotenuse is nothing but AC, adjacent side is nothing but AB, and this ratio is called as sec A. Sec A means nothing but hypotenuse divided by adjacent side, and this ratio we can also get by writing inverse of cos. That is 1 upon cos A also means that hypotenuse upon adjacent side. Why? Because cos means what? We know already. Cos A means adjacent side divided by hypotenuse, and if we take 1 upon cos A means hypotenuse will go to numerator and adjacent side remains in the denominator. Therefore, we can say that sec A is nothing but 1 upon cos A, or we can say that hypotenuse divided by adjacent side. These are the 6 ratios. We should be very thorough, because the whole trigonometry, it depends upon these 6 ratios: sine, cos, tan, cot, cosec and sec, and we should know their ratios also. Now I give you how to remember all these 6 trigonometric ratios. We have to remember only 2 ratios, sine and cos. That is, we should know sine is nothing but opposite upon hypotenuse and cos is nothing but adjacent upon hypotenuse. To get the third ratio, that is tan. If we want the tan ratio, what we have to do? We have to divide the sine ratio by cos ratio. That is sine A upon cos A. What is sine A? That is opposite side upon hypotenuse. What is cos A? Adjacent side upon hypotenuse. So these hypotenuse, they get cancelled. Here we get opposite side upon adjacent side. This is the ratio of tan A. We have already seen tan A is nothing but opposite side upon adjacent side. How we got this opposite upon adjacent side? That we got by dividing sine A upon cos A. Therefore, we also say that, we also know that, we should remember that tan A is nothing but sine upon cos. Now let us see the fourth ratio, how we can get. Here, to get the fourth ratio, we have to divide the cos by sine. The fourth ratio is nothing but cot. We have to divide cos A upon sin A. Cos means adjacent side upon hypotenuse, and sin A is nothing but opposite side upon hypotenuse. Hypotenuse get cancelled. We get adjacent side upon opposite side. This is the ratio of cot A. That means we can get cot ratio by dividing cos upon sine. In other words, we can also say that cot is nothing but cos A divided by sin A, or we can say adjacent side upon opposite side. Now let us see how to get the fifth ratio, that is cosec A. Cosec A. What we have to do? We have to invert the sin A, that is 1 upon sin A. We know that 1 upon sin A means what? Opposite side upon hypotenuse. This hypotenuse will go to numerator and we get hypotenuse divided by opposite side. This is the ratio of cosec A. Therefore, we can also say that cosec A is nothing but 1 upon sin A. Now let us see the last ratio, that is sec A. That is, we have to invert now cos A. That is 1 upon cos A. That is equal to 1 upon adjacent side upon hypotenuse. Hypotenuse will go to numerator. Hypotenuse will go to numerator and adjacent side will remain at denominator. Therefore, this ratio is nothing but hypotenuse upon adjacent side is nothing but sec A, and we have got sec A by inverting the cos A. This means that if we remember only two ratios, sine and cos, we can develop the remaining ratios very easily. I repeat, if we know sine A and cos A, we can write the ratios of tan A. How? Tan is nothing but sine upon cos. We can write the next ratio cot A. What is cot? We can get it by dividing cos A divided by sin A. Then the fifth ratio cosec A. Cosec A can be obtained by inverting the sin A, and the last ratio sec A can be obtained by inverting the cos A. So these ratios play very important role in solving the numericals. Now let us see two numericals. Here we go. Question. In the figure, tan A equal to 4 upon 3. Find sin A, cos A, cot A, cosec A and sec A, or the trigonometric ratios. How to do this? I have already told you that Trigonometry deals with sides of a right angle triangle and the angles. That means we should know the values of all these three sides. Here one ratio is given, that is tan A. Tan A is nothing but opposite side upon adjacent side. The value is given 4 upon 3. Here we have to observe this triangle from the angle A. That means we have to observe this triangle from the angle A. The side BC is opposite side. This is opposite side. The side AB is adjacent side and the side AC is hypotenuse. Tan A is nothing but opposite side upon adjacent side and the value given is 4 upon 3. That means opposite side is 4 and adjacent side is of 3 units. Now, as the trigonometry, it gives relationship between the angles and the side, we should know the length of the third side before we proceed. How we can find the length of third side when two sides are given in a right angle triangle? That is very simple. That is by using Pythagoras Theorem. Let us apply Pythagoras Theorem to this triangle. That is nothing but hypotenuse square is equal to sum of squares of remaining two sides. That is AC square is equal to AB square plus BC square. Here AC square we have to find out. AB is given, that is 3 square, and BC is given, that is 4 square. So 3 square is 9, 4 square is 16, therefore AC is equal to square root of 25, that is equal to 5. The length of AC is 5. Now we know the length of all three sides of a triangle. Now we can find out the ratio of any trigonometric. Now we can find any trigonometric ratio. Here we go. Now let us find sine A. We know that opposite side upon hypotenuse, that is opposite side is 4 units and hypotenuse is 5. Therefore this is the ratio of sine A. Now let us see cos A. We know cos A is nothing but adjacent side divided by hypotenuse, that is equal to adjacent side is 3, hypotenuse is 5. Then cot A. Cot A is nothing but adjacent side divided by opposite side, that is AB upon BC, that is 3 upon 4. Now cosec A. Cosec is nothing but hypotenuse upon opposite. Hypotenuse is AC, that is 5. Opposite is BC, that is 4. Last, sec A is nothing but hypotenuse upon adjacent. hypotenuse is 5, adjacent is 3. So in this way, we have found out the trigonometric ratio of sine, cos, cot, cosec and sec when one ratio is given. I summarize how we did this. Here tan is given. Tan is given means they have given opposite side upon adjacent side value. Opposite side is 4, adjacent side is 3. To find the remaining trigonometric ratios, we must know the length of all three sides of the right angle triangle. Therefore, we have used Pythagoras Theorem to find out the third side and we found it as 5. Now, when we know the three sides of a right angle triangle, we easily find out sine is nothing but opposite upon hypotenuse, cos is nothing but adjacent upon hypotenuse, cot is nothing but adjacent upon opposite, and cosec is nothing but hypotenuse upon opposite, and sec is nothing but hypotenuse upon adjacent. Let us solve one more example so that you will become more perfect. And this example I solve it in very short. Now you know the detailed method of solving. So now I will solve the example in very short. Here question 2. Sin A equal to 1 upon 3. Find the remaining trigonometric ratios. Here we do. We know that sine is nothing but opposite side upon hypotenuse. The value is given 1 upon 3. From angle A we are observing this figure. Therefore opposite side is BC, it is 1, and hypotenuse is AC, that is 3. To find other trigonometric ratios, we should know all three sides. The third side or remaining side can be found out by applying Pythagoras Theorem, that is AC square equal to AB square plus BC square. What is the value of AC? 3 square. We have to find out AB. BC square is nothing but 1 square. Now AB square equal to, I shift 1 this side, that will become 9 minus 1. 3 square is 9, 1 square is 1. Now AB equal to square root of 8. Square root of 8 is not possible, so we write 4 into 2. Therefore AB equal to, we can take the square root of 4, that is 2, and this 2 remains in the square root sign. Therefore the length of AB is nothing but 2 root 2. Now let's find the ratio of cos A. Cos A is nothing but adjacent side upon hypotenuse. Adjacent side is nothing but AB. Hypotenuse is nothing but AC. The value of AB is 2 root 2. The value of AC is 3. Therefore, this is the cos A ratio. Now, tan A. Tan A ratio can be obtained either by dividing sin A upon cos A, or we can simply use that opposite side upon adjacent side. Opposite side is nothing but BC. Adjacent side is AB. The value of BC is 1. The value of AB is 2 root 2. This is the ratio of tan A. Cot A. We can obtain the value of cot A either by inverting tan A, or we can easily write inversion of this, that is adjacent upon opposite, that is AB upon BC. What is the value of AB? 2 root 2. And what is the value of BC? That is 1. We can obtain the value of cot A just by inverting tan A. That means just inverting this tan A, we can also obtain the value of cot A. Now let us find the fifth ratio, that is cosec A. And we also know that cosec is inverse of sine. That means hypotenuse divided by opposite. Hypotenuse side is nothing but AC and opposite side is nothing but BC. Here we get 3 divided by 1. We can confirm here cosec is nothing but inverse of sine. That means 3 upon 1. Lastly, sec A. This is inverse of cos. That means hypotenuse upon adjacent. Hypotenuse side is nothing but AC. Adjacent is AB. The value of AC is 3. The value of adjacent side AB is 2 root 2. In this way, when one trigonometric ratio is given, we can find the other remaining trigonometric ratios by finding the third side by using the Pythagoras theorem. Once we know the three sides of the right angle triangle, then easily we can find out the remaining trigonometric ratios. In this video, I have tried to explain you what is trigonometry and what are trigonometric ratios, and I have also solved 2 numericals. In coming videos, I will take the exercise from Cbse and NCERT books, that is 8.1, etc. I hope you have enjoyed this video. Please subscribe my channel and press the bell icon, share the video and press the like button. Thank you so much for